Okay, so for our topic today, we are going to talk about factorizing. Okay, so we're going to learn the first type of factorizing here, which is factorizing out a common term. But before we begin with that, let's start with understanding what does the word factorizing mean. Now, to help you to understand that, let's look at this simple question over here. I believe you are very familiar on how to do this, and when we are doing this, what is this process called? When we are doing this way, this process is called expanding, right? Now, when you are looking at this question over here, what do you notice is missing? Alright, try to look. Before I expand, do you notice that I have some brackets here? And after I expand, there's no more brackets, right? So that is basically what expanding is. You are removing the bracket. So, having said that, the opposite should be true as well, right? So if I were to reverse the process, okay, if I were to reverse the process, that process is factorizing. Okay, if I were to reverse a process, that process is called factorizing. Now, when we are factorizing an expression or an equation, what will you notice is a bracket will be added. All right, always remember this. When you are factorizing an expression or an equation, we will be drawing back our brackets. Okay, so that is basically what factorization is, adding back brackets. Now, for this first example here, let's start with a simple example. I have this question over here. All right, my first example, I have 5a plus 5b, okay? Now, how do I factorize this out, okay? Now, when we want to factorize, we want to look something in common, all right? We want to find something in common, okay? So, let's try to look at this expression over here. What do we have, okay? So, if you look, I have some numbers here, right? And I have some alphabets here, okay? So let's look at the number first. What is something that is common between these two numbers? Alright, if you look at them, you might notice that both of them are divisible by 5. Both of them can be divided by 5, right? Okay, that's one thing. And then what about the alphabet here, the A and B? What's common, right? Beside them being an alphabet. Alright, nothing, right? So they're just alphabets, okay? So over here, the numbers and the alphabet, what can I take out? All right. Since they have these numbers have similarity, we can take out the 5 over here. And remember, when we factorize, we will add back the bracket, right? So if I were to take out 5 from this expression, I take out 5, what's left inside the bracket? So in this case, what's left inside the bracket will be just a plus b. Okay, so we have done with our factorizing already. Okay, so let's go through more examples so you can see what's going on over here. Let's try this example. 7x plus x squared. Okay, now again, this expression here, I have two things. I have my numbers. So I have my numbers, there's no number here, so that's fine. And I have my unknown as well. So what is the common thing that I can take out from this expression over here? So in this case, it's going to be x. Okay, I can take out x over here. All right. So if I take out x, how many x can I take out? So in this case, I can only take out one of the x, and what's going to remain inside this bracket over here? So what's going to remain inside this bracket over here? That's going to be 7 plus x. Okay, we're done. Now, what is something interesting about factorizing is this. If you want to know if you factorize correctly, you can just expand this expression back and see if you get back this expression or not. Because after all, they are factorizing and expanding are just opposites, right? So if I were to expand this back, I will get x times 7, I will get 7x, x times x, I will get x squared. So which means my factorization is correct. Okay? Now let's go through more examples so you can see how are different questions it can be when we are doing factorizing. So let's see here. Okay. Okay. So let's take a look at this question now. How do we factorize this? Again, we have the number here, okay? And we have some alphabet here, right? So let's look through the number first. What is something common that I can take out from 15 and 9? Okay? We will notice that 15 and 9, both of these numbers are divisible by 9. I can take out 3, right? Okay, I can take out 3 over here. But is that all the thing I can take out? What about the x over here? Can I take out something over here as well? Is there something common for me to extract from this expression? So in this case, it's going to be x, right? And it's going to be one of them, right? I can only take out one of them. So I have take out 3, I have take out x from here. So what's going to remain in my bracket now? Okay? So what's going to remain? So in this case, that's going to be 5. 5 is going to remain here, minus, all right, follow. What's going to remain here? That's going to be 3x. Okay? Done. Again, you can quickly check your expression if you factorize correctly just by expanding this back, and you should be able to get back this expression, right? Now let's try a much more longer expression and let's see how do you work this out. Okay, so I have this question. Okay, now I have more things right now in this expression. So let's identify what do we have. We have some numbers here, all right? We have some unknowns here, all right? The KKK, and we have some more unknowns here, all right? But if you notice, all these unknowns, X, Y, Z, are different, okay? So if they're different, we know that we can't extract them out, okay? We can only extract those that have something in common. So in this case, 2, 6, and 4. All right, all of these numbers are divisible by 2. So I can extract 2 out. Okay, I can take 2 out here. All right, what about K? Everything has K over here. I can take out the K as well. Okay, is there anything else I can take out? I have X, Y, Z. All of them are individual, so I can extract anything already. So that's all I can take out. So once I take out this thing from the expression, what's left inside the bracket here? Let's check the first one. Okay, this one has to multiply what to get this. So what's left? The thing that's left, that's going to be x only, right? Plus, okay, what is missing? So what's missing over here? That's going to be 3y. Okay, we can check. 2k times 3y, that's 6ky. And what's left over here? That's gonna left me with 2z. All right, done. Okay, same thing again. You can just express this expression and you should be able to get back the same expression over here. Now, last example. Let's try this one. Okay, again, let's try to factorize this over here. So again, when we look at the equation, let's try to look for something in common. So if you see I have a bunch of alphabets over there, let's try to identify which of the following alphabet we can extract. So let's say I have some a over here, but if you notice, I do not have a's over here, right? So I can't extract a out over here. But I have y. Oh, three of these have y, which means that this is the things that they have in common. I can extract y out. So how many y's can I take out right now? I can only take out one of them. Okay? Now what else do I have? I have my x. Okay? So I know I can take out my x over here. And in this case, I can only take out one of them. Okay? I can only take out one of them. So after I take out the things that have common in this expression, what's left inside the bracket now? So let's check the first one. What's left inside? That's going to be the letter A only. Plus, what's left inside here? I have taken out yx. So what's left inside here? That's the remaining is going to be it's going to be x squared. Okay? It's going to be x squared. And then minus, so I have extract this out. What's remain here? So the remainder will be 2yx. Okay, and I'm done. Once again, you can just expand this. This time this, I should get ayx. This time this, I should get yx cubed. And this time this, I should get negative 2 y squared x squared, which is exactly correct. Okay, so this is the first type of factorization, which is factorizing out a common term.